Okay, number one. They are going to say that DC is not really going through the center. It's a little bit shifted down below. If you said DC was the diameter, I don't blame you because it's very close to going through the center. I won't trick you with that on the test. It'll either be going through the center or it won't. It'll be very obvious, okay? So they're going to say DC is not going through the center, which means there's no radii. If it was going through the center, then you should have put DF and CF as radii. But we're going to assume it's not going through the center here. Chords then should have been AE and CD. Remember that CD is, if it was going through the center, is more specifically a diameter, but it's still a chord. Okay? Also remember the other one that most people will miss is AE, because there's a line going on. But every secant contains a chord. So if you stop it and put a segment above it, it's a chord. If you draw an arrow going on forever, then it's a secant. Okay, any questions on number one? Secant is a line that intersects the circle twice. A tangent is a line that touches it once, and then a chord is a segment that touches the circle. Really? The arrows, they're there on secant, and tangent is missing one right here. I don't know why. Oh, it is a ray. Sorry. That's why. Secant has the arrows and nothing else does. Okay? All right, number two. What's number two? 110 is correct. Questions on number two? What kind of angle is NMP? Central angle. What kind of angle is NLP? Inscribed. And I want to remind you that inscribed angles have to be made up of two chords, or they're not technically called inscribed. Inscribed angles have their vertex on the circle, but they also have to have two chords, not tangents, just not tangents. Okay, so what is NLP? Good, half of the arc NP. Okay, so that was reviewing the stuff we had done before. Any questions about that? Okay, let's just kind of talk about what we're going to be doing when we get back from lunch. We're going to be talking about finding the measures of angles that are formed by intersecting lines in circles. You already know two. Okay, you know the angle, if it is central, is the same as the arc. You know the angle, if it is inscribed, is half of the arc. And now we're going to talk about, after lunch, we're going to be talking about angles that are formed inside the circle that do not happen at the center. So maybe I'm looking for angle 1 or angle 2. Maybe the angle is actually outside the circle, so that it's happening here. And I want to find its measure. It's not a central angle, it's not an inscribed angle, so therefore it's going to have a different property. So we're going to be looking for measures of angles outside the circle, measures of angles inside the circle, but not at the center or inscribed. And that's why it's really important you understand central and inscribed before we learn these. The other thing I want to warn you about that students make mistakes with, I'll go back to this picture real quick, and then we'll go. Angle 2 is vertical to this angle over here. And we know that vertical angles are what? Congruent. But this arc is not necessarily the same measure as this arc, because this is not a central angle. And the only time the angle and the arc are the same is when the angle is at the center. So you can have vertical angles that are congruent, but vertical arcs that are not. Still confused, Lily, with what I just said? Okay, are you with me that if this is 30 degrees, then this is 30 degrees? But that's only because its vertex is at the center of the circle. If my vertex is not at the center of the circle, then this arc measure is not the same as this angle measure. So if this angle measure is 30 degrees, this is not 30. This angle, however, is 30. But these two arcs are not necessarily the same measure. Depends on where this intersects. As I shift that, notice It's very obvious here that these two arcs are not the same, okay? But these two angles are still the same because they're vertical. Gotcha. All right. Go to lunch, quietly down the hallway so nobody yells at Lashley. You guys ready? Back on your notes. Can we open the blinds and that way it's a little bit better in here so you can see the board? Christian or Haley, thank you. Can you see your papers? Okay, so here we go. Jumping right into theorems, most of your vocabulary has already happened. Notice most of the sections we had a ton of vocabulary. Now it's going to start to dwindle. First theorem, this is really very similar to what we did on Friday. It looks almost like it's an inscribed angle. That's why I emphasized before lunch. It has to be made up of chords to be called an inscribed angle. If it was an inscribed angle, we wouldn't need this theorem because we already have a theorem for it. But it has the same characteristic that the vertex is on the circle. So the way I remember it is, if the vertex is at the center, the arc's exactly the same. If the vertex is on the circle, whether it's technically inscribed or not, the angle is still half the arc. So where's your vertex? Is your vertex at the center so that it's equal? Is your vertex on the circle so that it is half of the arc? Or, and I'm going to skip this again and give you the big ideas first. So skip all of the practice problems. Go to the next theorem. So we have two types of angles, even though that theorem was about an angle not technically considered inscribed. The way I'm going to refer to it every time is where's your vertex. So if it's at the center, it's equal. If it's on the circle, then it's half the arc. And then we have the situation where it's not at the center, it's not on, but it's located inside the circle. So the next one I'll emphasize is just where is the angle located. The angle is inside the circle here, angle 1. If two secants or chords intersect in the inside of the circle, then the rule is the measure of the angle will still be half, but it's going to be half the sum of the measure of the intercepted arc and its vertical arc. Okay? So the measure of its two intercepted arcs. So if I look at angle 1 intercepts arc AB. Agreed? It's inside angle 1. The arc that is vertical to it would be arc CD. Those are not the same measure. We talked about that before lunch. But if I want to find the measure of angle 1, I simply add those two arcs, the one it intercepts and its vertical arc, add those together and take a half. So angle 1 would be the sum of arc AB plus arc CD times a half. If I wanted to find angle 2, then I would add AC and its vertical arc, BD, and take half of that. So it's half the sum of the two arcs, one that it intercepts and the one that it's vertical to. Are you with me there? Inside, add, and take a half. Because then we're going to look at what happens if it's outside, and it's very similar. So I'm going to skip this for a second, skip the examples, and go to, this one. So now notice where are the angles on every one of those pictures? Outside the circle. Angle 1's outside, but it's made by a secant and a tangent. Where do you see that? Oh, yeah. Angle 2 is outside, but it's made up of two tangents. 3 is outside, but it's made up of two secants. So it doesn't matter whether it's two secants, two tangents, or a secant and a tangent. If the angle is outside, then exterior, then the rule is the measure of the angle is equal to half the difference of the two intercepted arcs. So we're still talking about the intercepted arc and its vertical arc. So look at number 1. The arc that it intercepts is arc AD. Agreed? The one that then would be vertical to it, or the other one that's inside the angle, would be arc BD. You're going to subtract those two arcs and take a half. Look at the next one, see if it makes sense on here. The arcs that it intercepts are arcs EHG, and arc EG. So you'll subtract those and take a half. Look at the next one. Angle L, or angle 3 as they've called it here, intercepts arcs JN and KM. It's the ones that are inside the angles, not the ones outside the angle. You're going to subtract them and take a half. Always doing the big arc minus the little arc so that you have a positive measure. Are you guys with me? Okay, notice one thing about the one in the middle in blue. EHG and EG, when you put them together, what do you get? Whole circle. More than likely, they're going to give you problems where they're maybe going to tell you this is 120 degrees and that is it. How are you going to find the red arc? You're going to take 360 and you're going to subtract 120. Biggest mistake I usually see is students think I subtracted, so now I'm ready to take a half, because it's half the difference. But you subtracted not big arc minus little arc. You subtracted just to find that missing arc so you could work the problem. So be very careful. 360 minus 120 is 240. That's this red arc. Then you're ready to plug it in. 240 minus 120 times a half. Okay, so big arc minus little arc, and it's the arcs inside the angles. When you're looking at the picture, the arcs inside the angles, the arcs it intercepts. Questions? It's the four big ideas. Central angle is the same. Inscribed angle is half. So this would be 15. If it intersects inside the circle, then you're going to add them and take a half. If it's outside the circle, you're going to subtract them and take a half. And those are your four kinds of angles. Let's practice some problems. So go back to the beginning. Angle EFH, where's the vertex? On the circle. Again, ask yourself every time, is it at the center? Is it on the circle? Is it inside the circle? Or is it outside the circle? And in this case, EFH has its vertex on. So what's the measure of the angle? Half of the arc. And half of what in this case? 130. Half of the arc that it intercepts, which is 130 degrees. And so that is 65 degrees. Okay? Very easy. Next one. Arc GF. Arc GF. So arc GF is asking you for this arc here. Okay, so you got to put it together. First of all, what is this 122 degrees referring to? Yeah, I'm going to put a D here, okay? So FGD, right? When they give you an angle measure, they'll give it inside the picture next to the angle. When they're giving you an arc measure, they're always going to put it outside the circle. So if you're ever confused about what are they giving me, if it's outside the circle, it's referring to the arc. When it's inside here, that means they're giving you this angle measure. Okay, if that's 122 degrees, then what is angle FGC? 58, because they're what? Supplementary, because they're a linear pair. Bless you. So that's 58. Now how does that help me find arc GF? Good, because this angle has its vertex on the circle. So if it's on the circle, then it's half of the arc. Therefore, the arc must be twice the angle. And so what do we get? 116. Everybody with me? Okay. They're going to get harder because you're going to have to be filling in things we learned before, finding pieces maybe you don't need to get the piece that you do need. Does that make sense, Olivia? All right. Okay, go to the next one. A, E, B. Where's the vertex?
Not in the middle.
Okay, it's not at the center, but it is inside the circle. So we know it's not going to be exactly the same as the arc. It's going to be half the what? Sum. So we're going to have to find the two arcs that we need to add and take a half. Which two arcs do we want to add? AB I heard, and DC. So again, if you're confused which two arcs, it's the one inside the angle you're referring to and the one that is opposite it, or the one that is created by the vertical angle. So I call them vertical arcs. I don't know if that's technically correct terminology, but the vertical angles create arcs, and those are the two that you're adding together. So we're going to add 1/2 of 139 plus 113. Help me out. Is that 250? Thank you. And half of that is? And don't forget your degree symbols. So inside is half the sum. Questions on that one? Okay? So then we have the outside angles. Here we go. First one says find x. X is the angle that is outside the circle. So one more time, it should be half the difference. Which two arcs, though, are we referring to subtracting? GC and DF. Big minus little. So what am I going to subtract here? 87 minus 7. Keep in mind, they're probably not always going to give you the measures. You may have to use the fact that a full circle's 360 and find some missing arcs first. They're going to get a little harder. What's 87 minus 7? 80, and half of 80 is 40. So outside, half the difference. Questions? Okay. B, again, we're looking for angle DCB, or X, which is outside. So what two arcs do I want to subtract? DA minus DB. So inside the angle, this big arc minus this little arc. So half of 200 minus 74. What's 200 minus 74? 126, and half of that is 63 degrees. Questions? And I'm even going to make one up just to make sure that's even harder. Okay? Okay, here we go. In the company logo shown, the measure of arc FH is 108. Which direction do I go from F to H? Shortest distance, because it was 2 letters. So I'm going to go from F to H, and H is all the way over here, and that's 108. Okay, measure of arc LJ. One more time, it was 2 letters, so I'm going the shortest distance from L to J is 12 degrees. What is the measure of angle FKH? They made that look really hard, but it turns out to be no different than what we've been doing. Right? The angle's outside, so it's half the difference. They didn't even make it tough and give me FG, they gave me FH. So what am I going to do? Good. Half of 108 minus 12. What's 108 minus 12? And half of 96 is? 48. Don't forget your degrees. Any questions? Okay.
What a coincidence. I need to go to the eye doctor today.
Awesome. Well, 2 of the 6 muscles that control your eye movement. So when you walk in, you can say, hey, did you know there's 6 muscles that control eye movement? I learned that in geometry today. And he'll probably be like, there's actually more than that, and your geometry teacher's an idiot. That's fine. That's fine. 2 of the 6 muscles that control eye movement are attached to the eyeball and intersect behind the eye. If the measure of arc AEB, so which arc are we talking about? Bigger one. So major arc, AEB. Okay, that is 225 degrees. What is the measure of angle ACB? So where's the angle? Outside. So we're going to do 1/2 of what? (225) minus, how are we getting that other arc? Good. And again, I'll warn you, I promise somebody will do it if you're not careful in your mind right now to say, okay, I'm not going to make that mistake. You have to find this arc, and to find that arc, you're doing 360 because the full circle, subtracting the other part, 225, and you got 135. Don't get in the habit of doing that and then thinking I already subtracted, so I'm just going to cut that in half and say that the answer is half of 135.
That's wrong.
That is wrong. So I would do my work kind of over to the side to find that arc so that then when I plug it into my formula, I don't make the mistake. What's 225 minus 135? 90. Half of 90 is? Don't forget your degree symbols. Any questions on that? Okay, this is just putting it all together in one little nice pretty chart for you. Is your vertex on the circle? Is your vertex inside the circle? Is your vertex outside the circle? And you may want to put a little note over to the side that the 4th one was, is your vertex at the center of the circle? Because then, whatever this angle is, the arc is the same. Okay, because that was your 4th one. That only has the 3 situations. Probably trig, special right triangles and trig. That was in chapter 8. Any questions? Okay, look at this one. Arc YZ. See if you can find it on your own. This is the last one. Okay, good. Find arc. Oops. I kind of just gave it away. Find arc YZ. Just start filling in anything you can figure out. Here, most people, when I was walking around, are at least getting the idea that if this is 113, what's this angle? 67 degrees, which means what's this angle? 67, which means what's this angle over here? Okay, so those are some steps. Start finding everything you know for sure. And then I want to remind you one more time that this angle is 67, but notice this arc is not 67. That's not the center. They're not the same. So same goes here. If this one's 67, this arc here is not 67 because it's not the center. Okay, so be really careful there. Write down your formulas. I see a lot of people kind of stuck and not sure what to do or had the wrong answer, but when I'm asking what are you doing, they don't have any work down. They're trying to do too much in their head. Write your formula down. So first thing I would notice is this angle is 67 and it's inside. This arc is what it intercepts, which is 68. This angle should be half of the sum of this arc plus this arc. Agreed? Inside angle is found by doing half the sum of the 2 vertical arcs. So this angle here should be half the sum of these 2 vertical arcs. Stop me right now if you don't understand what I'm talking about. The angle, YXU. 49 is going to this angle right here. Okay? So are you with me, Hannah, that this angle is inside the circle? The way we find that angle is by taking half of the arc that it intercepts and the arc that the vertical angle intercepts. Right, but we're going to find it. So that's where I was saying you've got to write down your equation. You have to plug in what you know, and sometimes you have to work backwards to find what you're missing. So I know the angle. I know this arc. I don't know this arc. That's the only thing I don't know. So if I write my equation down, the only thing I don't know is that arc, and I can find it. So my relationship was angle. This is kind of how I write it all the time when I do my work. Angle equals 1/2 of arc plus arc. There's you a formula. If it's inside, it's 1/2 arc plus arc. And remember, it's always big arc plus little arc. When you're subtracting on the ones outside, it'll be big arc minus little arc. So now plug in what we know. We know the angle is what? 67. And that should equal 1/2 of, what is one of the arcs? 68. Plus, what's the other arc? We don't know, I just called it x. And now we're going to show our work. So we're going to multiply both sides by 2. 2 and 1/2 cancel, and I have 134 equals 68 plus x. Subtract 68, what is x? Okay, show me your work. If you're doing it in your head or doing it on your calculator, I can't grade that. And that's not going to let me be able to give you partial credit if you make a mistake. It's also not going to give you credit on your homework if all you do is give me an answer. So x is 66, but that's not what I'm looking for. That's just this arc right here, 66 degrees. Wants me to find arc YZ. So now I'm back over here with what I'm looking for, arc YZ. I know this angle. I know I'm looking for this arc. I know this angle's 49. I know the outside angle should be half the measure of the arc that it intercepts, big arc, and the little arc that it intercepts, subtracting that. Is everybody with me there? It's outside. This arc is the big arc. This arc is the little arc. And now that I know the little arc, I should be able to find the big arc. So let's write our equation. Angle equals 1/2. This time it's outside, so it's arc minus arc. What's the angle? 49. 1/2 of, what's the big arc? We don't know. That's our YZ. That's what we're looking for. Minus, what's the little arc? 66. Now work backwards. Multiply both sides by 2. So now we have 98 equals YZ minus 66. Subtract, or add 66, sorry, and what do we get? 164 equals the measure of arc YZ. Don't forget your degree symbol. Yes, ma'am. What'd you do?
We did do we found the 67.
Okay.
Vertical angle and then added 49 plus 67. And subtracted that from 80 again. That was, we just multiplied that by 2. That angle.
You found this angle, multiplied it by 2. That gave you this whole arc. Good. Yeah, because you're finding the measure of the outside pieces and looking for the other piece. So I don't know if you guys caught. Let me repeat one more time what Meg said. Make sure you're with her because it's a great alternative. She said that they found this angle was 67. They looked at this triangle. You guys see the triangle? They said 67 plus 49 and subtracted that from 180 to get this angle measure, which was 67 degrees. Oh, 64, okay? And then they said 64 is this angle, so that means since its vertex is on the circle, the arc that it intercepts here should be twice 64. So they found out that that meant this was 128 degrees. This was 68 degrees. Added those together, and the remainder of the circle, which is what they're looking for, should be YZ. Questions? Okay, I want you to look at the board. Another kind of question you might see on the homework and definitely on the test. Find X. So I'm going to give you a few minutes. I want you to see if you can come up with an idea and see if you can find it. Two, for sure, correct answers worked two completely different ways. So that's really cool. And one way I haven't ever thought of. So I'll be happy to show that. Zachary, he's awesome like that. So if you will look up here with me. First of all, if this is outside the circle, what's my formula? Okay, angle equals, good, 1/2 of big arc minus little arc. So the challenge here is to only have one variable, because if you have more than one variable, you can't work the problem because you only have one equation. So start with, we know the angle is 20. 20 equals 1/2 of. Big arc is what we don't know. That's this. But how could we find it? Good, 360 minus this piece, which is x. So we know this is 360 minus x. Plug it in. 360 minus x is the big arc minus, what's the little arc? X. And now you have an equation written all in terms of one variable. You should be able to solve it. Order of operations says you always work inside your parentheses first. I can't simplify 360 minus x. Can I simplify the next set of parentheses? What's 360 minus x minus x? Good, 360 minus 2x. Then we work solving, trying to get the variable by itself. So what do I do from here? Multiply by 2. When I multiply both sides by 2, that'll cancel out the 1/2 so that I have 40 equals 360 minus 2x. Now what? Subtract 360 so that we have negative 320 equals negative 2x. Divide by that negative 2, and what is x? 160 degrees. Questions on that before I show you an alternate way?
Was that the way that you thought of?
This is the way I would normally work the problem because I'm very algebraic in my mind. So I think equation, formula, solve formula. Love it when somebody is more geometric in their mind and sees geometry type pictures. So kind of like Lily and Meg did on the last one, coming up with that, looking at it from the triangular perspective. That's what Zachary did here. So he said, I'm going to connect A to B, and I'm going to make myself a triangle. If I make myself a triangle, then that means that since these two are tangents, what did we learn about them earlier? They're congruent. So these two should be equidistant, right? So now what kind of triangle do I have? Isosceles. So that means this angle and this angle have to be congruent. If this is 20, then what does the sum of these have to be? 160. But since they have to be congruent, what's each one? 80. So then he said, this is 80, and I'm looking for x. And since this has its vertex on the circle, then that means this angle is half of this arc. So that means x is twice 80, which is 160. Andrea. Awesome. Hold on. Can you hold on just one second? Anybody not understand what Zachary just did? Because we learned today, the very first theorem said if the vertex is on the circle, so for this angle right here, this angle 80, the vertex is on the circle, then the angle is always half of the arc that it intercepts. So if the angle is half the arc, then the arc is twice the angle. So the arc is twice 80. Awesome. Andrea, go.
Okay, well, I did this from A to B. I made a radius to the center and made it to where, like, the tangent is 90 degrees. And then I got 180 plus 20 is 200, then did 360 minus 200 is 160.
Very good. Okay, make sure you're following Andrea there. This is awesome. I love these wonderful brains you guys have. Okay, so are you following here with Andrea that she can connect B back to putting a center in her circle and A back to putting a center in her circle? And that we learned that a tangent and a radius meet at the point of tangent C and are always perpendicular. Do you guys remember that? So this is 90 and this is 90. Does everybody agree? And this is a 1, 2, 3, 4-sided quadrilateral, which should always add to be 360. So she said 90 plus 90 is 180, plus 20 is 200, which means this angle has to be 360 minus 200, or 160, and the central angle is always the same as the arc. Love it. Other questions or other ideas? Yeah. Great plans. And then if you're like me, you're sitting there and you didn't come up with one of those three and you think, man, they are stinking smart. Why didn't my mind think of that? I get frustrated. Any questions in this section? All right.